Welcome back to my game programming tutorial. We'll be programming a game with processing 3.5.3. In my opinion, processing is probably the best language to start out learning programming. It's actually a subset of Java, so if you learn it, you'll be learning Java, but it makes graphics very easy, and I think probably one of the best ways to learn is to just open up the examples that it provides and start modifying them. Um, I'm not going to modify any examples right now, but I'm going to show you how to make a top-down game. In the last video that I made, I created a basic map and displayed it on the screen. I'm going to show you what that looks like. It just loads a map that's 50 by 50 tiles, and right now it only sets the map to just the one tile, which is the grass tile. So today what I'm going to do is display the character on the map and have him move around, and also um, make the map scroll when he moves. So what I'm going to do, the best way to do this is to create a class for the character. So we have class, and we'll call it player. Um, so the player will have some properties. One of the properties that it needs to know is its position. So we'll make a what's called a p vector and call it position. And the p vector is basically just the a set of coordinates for the player. It's a data type that processing provides. And the advantage of using a p-vector is that there's all kinds of different mathematical functions that you can do that use this as the data type, so it's just an optimized way of working with coordinates. Then what we need to do is also we can define the player's velocity, so that can just simply be a floating point value. I described what a float is in the last video. It's just a value that can have numbers past the decimal point, whereas integer numbers do not have any numbers past the decimal point. So I'll call this velocity, and then what we need to do is create the constructor for the player, and the constructor we can actually, let's go ahead and set in a p vector and call that I position for initial position. So we say position equals I position, and then we can set velocity equal to let's say 0.5 for now. So that means that every frame the player will move 0.5 pixels in whatever direction that they're trying to move, and that kind of makes sense, being that we're going to achieve frame rates of like 20-30 frames per second, maybe possibly even higher than that. So if we had a greater number than this, the player would just move ridiculously fast across the screen. So let's see here. Now what we should probably say is we can make some methods to move the player up and down and left and right. So we'll say move up, and I'll copy that to make the other ones. There are other ways to do this, but this is just kind of an easy way to set up the player so that the rest of the program that's making the player move doesn't really have to understand the mechanics of how the player moves. So in this case, we can say position dot y equals position dot y will be equal to velocity times -1, because the coordinate system in processing is where the upper left hand corner, let me show you here, the upper left hand corner of the screen is 0, 0, and then the y value increases as it goes down. So if we want the player to move up, then we have to move it in the negative direction in the on the y axis. So that would be the velocity, 0.5 times -1. So each frame it'll move negative 0.5 in the y direction. So to move down, we want the y to equal velocity, because that's, again, it'll be 0.5, an increase of 0.5 in the y direction, which will be moving down. To move left and right, the to move in the left direction, it'll be a negative value on the x-axis, and to move in the right direction, it will be a positive value on the x-axis. Whoops, position dot x equals velocity. Okay, so oh, whoops, I'm sorry about that. Let's see here. So we have to add the position value. So basically, it'll be like the value that the player was in the last frame plus the velocity. So each frame it'll move just that little bit from where it was in the last frame, depending on what the direction is that they're trying to move. So that's why, I'm sorry, we have to do plus equals, plus equals, plus equals. Okay, so so now we want actually to make the player display. So we'll say void display. And in order to display we need to actually have something to display. So I'll make a p image. I'll call it sprite. And we'll make this better in the future. Right now it'll only be one p image. There won't be any animation. But in the future we will be able to animate the player. So in here, actually, we have to make sure it loads the sprite. This is again the constructor that gets called when you actually create a player. So we'll say that sprite equals load image, and what we need to do is actually specify an image file. And I've actually gone ahead and created one previously. So this is the data that our program uses so far, which is just the map tile. So we need to add player tiles to it. So actually, I have 4 player tiles here that I was using in the original version of this program that I made. So I'm just going to go ahead and copy those in. So I'm just going to use the first one here. If you can see, it's pretty basic image. Now I've noticed that there's actually a problem loading the images that have transparency. So I'll have to create a function in the future to actually create transparency around the player. I'll show you that in a little bit, but for now, what I'm going to do is just go ahead and load that image. So all I need to do is just copy the name here, player. Okay, and then what we want to do to display it is just say sprite dot image. That's the function that we use to display things in processing. And then what you want to do is, oh, oops, I'm sorry. What we need to do actually is call the image function and pass in sprite as a parameter to it. And then we want to make sure it displays at the position that we want. So it's going to needs an x and y coordinate. So position.x, position.y. Okay, so that should allow us to display the player wherever the player's position is. So what we want to do now is actually create the player. So we'll do that in the setup function. Again, processing has 2 main functions or methods, whatever you want to call them, that it uses, and that is the setup function that gets called once and only once at the very beginning of the program, and then it calls draw over and over again continuously to keep drawing frame by frame by frame what happens. So Okay, so what we need to do first is actually create a global variable here, a global variable to store the reference to our player object. We'll call it player1, and then what we need to do is to set player1 equal to a new player object. Since the player1 that was just a reference to an object, it didn't actually store an object yet, or it didn't actually reference an object yet, so now we're going to create an object for it to reference. We do that by saying new, we want a new player, and that player is going to be at, if you remember, this takes a p vector as the input here to create a new player, so it needs basically the initial position. So we'll create, again, the p vector is also a class, so we need to create a new object of it, and we'll say the object will be at 50-50. So that should be it to create the player. Now what we want to do is actually display the player when we draw. Again, remember this calls draw over and over again continuously. So what we want to do is display the map first. The order is important here in which it draws. So you can imagine it'll draw the map first, and then you're going to draw the player on top of the map. If you draw the player first, then the map will basically display over the player, and it'll just, cover up the player. Okay, so what we want to do is just say player1 dot display, and that will just display the player wherever the player's coordinates were set to. And we're not going to move the player yet. I'll just show you that this actually displays the player now. So you can see we have the player displaying here. It doesn't have any transparency yet. Again, that's saying I have to make another function here to put transparency on the player. So what we'll do is we'll actually go ahead and start to try to take in some keyboard input to move the player. Now, there's a number of ways to do this. The best way is actually to create a class for the controls. And this is because we want to potentially edit in the future the way that the controls are handled. So anyways, this will allow us to just more easily organize what we're doing here. So I have to create a constructor function here for the controls. It doesn't need to do anything for now. We don't really have any specific things that we need to send into it. It can be pretty basic here. So anyways, what it needs is a function to check the controls. So we just call it a check. That is an empty function. It doesn't have any parameters but it'll pass into it because it doesn't need to know anything. It doesn't need to have any input in order to just know how to check. At least not the way that we're doing it right now. So what we want to do is so we want to check to see if there are any keys pressed, and the way you do that in processing is you say if key pressed, then you can do whatever if a key was pressed. So so this key pressed, it's a global Boolean value, which means it can have only two values, which are either true or false, and it can't be any other value than that. So if in the if statement we'll say if key pressed is equal to true, basically is what this is saying, then do the stuff inside of here. So let's put some stuff inside of here to do. So what we want to do is actually check the what the key was that was pressed. So if the key is equal to, and I'll use like WASD for the controls in this case. There's different ways to check if you are pressing like the arrow buttons, but I'm just going to use WASD here. So I'll say if key equals W, which would be like up. If you're using a WASD setup, then we want to do player1 dot move up, and then we could say if key equals to S, then we could say player1 dot move down. And then we have if key equals to A, player1 dot move left, and if key equals to B, player1 dot move right. Okay, so now I got the controls here set. So what we need to do is actually check the controls each time. So we could do that really anywhere inside of here. It's better to execute all the physics before you do any drawing, and execute all the controls of the game before you do any drawing. So that way you have everything all worked out first, then you can draw it. So what we want to do is have the well, actually, I'm sorry. First, what we need to do is actually create uh, a controls object so that the program actually has something to work with here. So again, the Java distinguishes and processing distinguishes between uppercase and lowercase letters in the name. So this is totally, it thinks of this as totally different from this. So this is telling us, making an object, a reference to an object called controls of the class named controls. So what we want to do now is, just like we did with the player, go ahead and set controls equal to a new object of the controls class. And that doesn't actually take any parameters to create the object. It just is a pretty basic object. So I created a new controls object. So now we have a controls that we can use, and we'll say up here controls.check. So that says check the controls, and that should be able to check the keyboard being pressed and then move the player around if there was any keys pressed. So let's go ahead and run this, and now as you can see, I'm moving the player, I'm pressing the keys and it's moving the player around. Actually, it's moving quite slowly. It may actually be because the frame rate is kind of slow here, and I'll show you later on how to improve the frame rate. The way that we're actually displaying the map tiles, being that it's actually displaying each individual tile, like 1, 2, 3, 4, 5, 6, displaying each individual tile here. It's making the player move quite slow. It's making the frame rate rather quite slowly, and thus everything that's dependent on the frame rate will also move slowly. So there are ways actually, and this is one of the reasons why it's a good idea to create the methods for moving the player inside of the player class to control how the player moves, because there are some things that we can do to make the player move at a constant speed relative to time rather than being relative to the frame rate, which it is now. So I'm not going to do that right now, but that is a common practice in game programming. What I'm more concerned with right now is actually just showing you how to scroll the map. So let's see here. So what we want to do actually, I'll go ahead and I'll start the player out in the very middle of the screen. So if you can remember in processing, when you call this size function, this creates the window for drawing. It creates it at 800 pixels by 800 pixels, and it stores these two values, the width and the height, in variables called width and height. Those are just variables that processing gives you, so you can do some calculations to figure out the center of the screen. So width divided by 2 and height divided by 2 should give you the center. So this is how I'm initializing the player. I'm saying set him to the position of, whatever this is here. So this is the screen width divided by 2 and the height divided by 2. So I'm going to do that because I want the map to stay centered on the player while it moves around. And so let's see here. So basically what I want to do is I'll create also another variable here called or another a p vector called screen position, or rather I should call it map position. Actually, what was better is actually to put this in the map itself. Since the map has a display function, it can use that inside of the display function. So we'll say p vector map position, and in here we can set the map position. We'll say map position. Actually, I'm sorry. Let me just make this lowercase. Is better naming conventions since it's a variable that can change. So we'll say map position will equal new p vector, and we'll set that to 0, 0, just like it is displaying right now. And then when we display each thing, we'll actually remember, this is the image. We're imaging the map tile that's in the palette at this index in the map tiles, and it just goes through each one of the map tiles and displays it at this equation, which is basically display 50 in the x-axis and then 50 down the y-axis. So basically what I need to do here is to offset this by the screen position. So what I want to do is I'll set that to map position, and I'll also set this one to, oops, actually I'm sorry, map position dot x, and I'll set this one to add map position dot y. Okay, so that will always add on the map position, so that you can see what happened, where the map is moving. Let's see here. So what we want to do is whenever we move the map, or whenever we move the player, we want the map to move as well. So we can also add functions just like we had with the player here to move the map. So we can pass in a velocity to move the map whenever we're moving it, because the map shouldn't necessarily need to know what the player's velocity is, yet we want to move the map at the same velocity of the player. So we'll say float v for velocity. Well, actually no, we'll just call it float velocity because we already have the code here. So float velocity, and we'll rename this to map position in just a second here. So I'm just going to copy it and paste here so that we're manipulating the map position, which is part of the map class. So these functions now should be able to move the map. So what we want to do is actually, the best place to do this probably is in the controls. So that, again, this is one of the reasons why you have a controls class, because you can change up how you're actually manipulating all the objects in the world. So I'm going to say map, oops, let me see what I call it up here. So the map is just called, it's just called map. So we're going to say map dot, I'm going to just copy this here actually from the player, map dot move up, because the name of the function is the same. So map dot move up, and then the velocity, we're actually, again, we want to take the player's velocity, so player dot velocity, whoops, I'm sorry, it's player one dot velocity. So I'm going to copy that and paste, and then just kind of, so I can do this faster, map dot move left, map dot move right. Okay, so now that should make the map display in a different position whenever we actually move the player around. What we want to do is let's go ahead and run this now and see what happens. So now I'm going to move the player around. So actually, yeah, as you can see, I'm moving the player. Actually, the map is scrolling with the player, but actually this doesn't really make sense the way that it's moving. As you see, the map is moving with the player, as if the player is as if the whole world is just moving and the player isn't actually walking around. So the reason for that is because the map, actually, if you imagine the player is going to move, the map should move in the negative direction that the player is moving. So what we want to do is, in the map move function, actually what we want to do is just invert the way that it's applying the velocity. So in here, this will be just velocity, this will be velocity times -1, this will be just plain velocity, and then this will be velocity times -1. So I just inverted the way that the direction that the map moves whenever you move around. So let's go ahead and see what happens here. So now I'm moving and the map is scrolling, and then the player, however, looks like he's moving extra fast relative to the map. And the reason for that is that I said that I wanted the map to move but the player to kind of stay in the center of the screen while the map is moving. But what I'm actually doing is I didn't change it around because the player was already moving around by itself relative to the actual screen and not to the map. So what I want to do is make the map move around, like the viewpoint on the map move around relative to the player's position. So basically what we need to do is the player's position in the world should change. It's only the way that we're viewing the player that needs to to be different. So so in the player's display function, we want to make the player display relative to the map view. So what we'll need to do is actually pass in some information to the player's display function so it knows like what it's displaying relative to. So we'll say p vector, and we'll call this screen position, because it doesn't necessarily need to know that it's relative to the map, but is relative to the screen position that we're at. So anyways, when we're actually displaying the player in the draw function, this is where we want to control what the screen's position is that the player is displaying relative to. So we'll pass in the maps, the map position, so the player can display relative to that. And we didn't actually manipulate anything here based on the screen position. So what we'll do is we'll say, let me see here. So we'll say position.x plus the screen position dot x, and position.y plus the screen position dot y. So that should display us relative to the way that the screen is moving. So let's see here. So yeah, so now you see it looks like the player is actually moving relative to the map. So if you see up here though, the map is kind of like scrolling down and it's leaving this green. That's because we actually are hitting the edge of the map, but it's one thing it's not doing is it's not clearing the background out before we draw the map. So it actually just will it'll essentially what it's doing is it's drawing a trail of the upper edge of the map here, and it's making it just look like this solid green because it's just this upper trail of just one long line of green on the map. If I could change, I'll change the tiles and you can see actually the trailing effect more prominently, so you can tell what's going on here. And then we'll fix that in a second afterwards. But so what I'm going to do, I'm just going to go ahead and make some variation to the tiles. This is when we created the map. We're not specifying what the tiles should be anywhere yet. It just created let me see here. When it creates the tiles, this is the list of the tiles. This stores the data of what the tiles actually are going to display as. It just creates, basically the way Java works is that when you create a new array, it just sets everything to 0. So that's what's happening right now, and 0 represents the grass tile. So what we want to do is add some variation to it there. So we can say for int I equals 0. Now this is like a very basic kind of pattern that you'll do in programming. It's just to loop through an array. So we'll say tiles dot length I plus plus. So this basically just tells the program to loop over and over again and do something inside of this block here. Oops, so I want to say I is less than tiles dot length. Okay, so it's going to tell the program to just loop inside of here and start from 0 with this I variable, start from 0 and then loop until the value of I is equal to 1 less than the tiles dot length. And that makes sense because the indexes start from 0 and then they go up to 1 less than the tiles dot length. And the length of the tiles is will be this right here, which is 50 times 50, but the indexes will go from 0 to 50 times 50 minus 1 because That's just indexes start from 0. If they started from 1, it would be all the way to the value length. So anyways, it's just going to loop through each one of the tiles in the array here. So we'll say tiles I is equal to, and we can say what we can say here is actually I mod we have this map tile palette which defines the tile palette that we're using. So we can say map tile palette dot length. So okay, so there you go. So now, yeah, I created a map. And basically, this is just putting different map tile image based on when it creates the map. So now you can see this trailing effect, which I was kind of talking about before. That's all I was trying to kind of illustrate here. So that's because we're drawing the map over and over again, but we're not actually clearing the pixels on the screen before we draw the map. So it's just going to trail whatever's here. Basically, this part is overwriting constantly with new frames of the map each time, which is why you don't see any trailing here. But over here, it's not drawing anything, so the last thing that was drawn is just going to keep displaying constantly. So what we want to do, just to fix that part here, is to we'll say clear, and that just clears out the screen. I think it clears to the value 0 by default, which is black. So yeah, there you go. So now it's clearing out the screen before it draws anything. So just imagine it like clears the entire screen to black, then it draws the map, then it draws the player, and then it outputs it to the screen. So that's why each time that it cycles through each frame, it'll draw black first, and then you have a black background always where it's not drawing the map. So anyways, that's basically we have a really basic system of scrolling for the map now. Next time, what I'll do is I'll actually show you how to make it so that if your player comes to the edge here, you don't actually display the black. Instead, the map scrolling stops, and then the player continues to move in these whatever directions this is. So I'll show you that next time. Okay, so yeah, make sure to check out my Patreon. There you can actually download a demo of the game that I made and get the code from the demo. The code is definitely more advanced, but you can also download all the pictures, all the images that I use, the graphics that I used for the program, and then you can recreate what I'm doing here without having to make your own graphics. And if you want, go ahead and make a donation. I'll actually complete this game, and it'll get better and better as time goes on. And then you can play the full game in the future if you're interested. So yeah, thanks for watching my video, and I will see you next time. Peace.